asking everybody today if they know anything about equivalent numbers. So, do you know what the equivalent number to 4/8 would be? Like a decimal form, maybe.
5?
Excellent, good job. Nicely done. Thanks. So, first question is, do you know what a ratio is?
Yes.
Okay. Do you know what equivalent means?
Yes.
Excellent. Okay. Do you know the equivalence of 1/2? What that equivalent number would be?
1/2.
Right. And what would another equivalent number for that be?
0.5.
0.5. Excellent. Good job. All right. Thank you very much. So, do you know what an equivalent number to 1/2 would be? No? No? That's okay. No worries. No worries. Have a good day. All right. So I'm asking about equivalent numbers. Do you know the equivalent number to 4/6?
No.
All right. It would be 0.66.
In the infinity, yeah.
Exactly. How about 1/2?
Well, another half is a whole. For the opposite.
No, it's going to be the decimal version of 1/2.
Oh, 0.50.
There it is. Excellent. Thank you, sir. All right, students. Do you know how to find equivalent rational numbers? Well, let's find out. Math.
Equivalent rational numbers.
Well, students, now that we're at the board, we can look at equivalent rational numbers and figure out, are they the same? All right, so let's start looking at some key terms. The first one is rational number. Now, a rational number is any number that can be written as a fraction where both the numerator, the top number, and the denominator, the bottom number, are integers, and the denominator is not equal to 0. Now, that makes it really hard, but here's a simpler definition. A rational number is a number that can be made as a fraction of two integers. The integer itself has no fractional parts, so it would just be two numbers. Our second key term here is equivalent. In mathematics, equivalence means a number or term is equal to another one in value, amount, or function. But again, a simpler definition would be that something like 1/2 is equivalent to or the same value as 0.5 if you just divide it out. We're going to learn how to write rational numbers in equivalent forms. So when you're given a rational number, it can be written in various different forms. First, we'll take the example of 1/2. Pretty common fraction. So we can take this number and we could write it in another way. For example, 2/4. Those are exactly the same. We could also rewrite it as 3/6. Or we can write it as 50/100 or 50/100. Because all these numbers, if we divide them out, we would get 0.5. So all of them are equivalent or equal in value. So how do we know if they are all equivalent or the same value? Well, if you're given a fraction, you can just divide it. So we'll take the number 4/6. If we divide this, we're going to go into old school long division just for a moment, just to prove this point. Here we go. We take the 4 and we divide it by 6. Now 6 we know can't go into 4, so we put a 0 there. Then we're going to be going into decimals because it makes sense that a decimal is a fraction of a whole number, and a fraction, clearly in the name, is a fraction of a whole number. So we put a 0 here. 6 can go into 40 6 times, which is 36. So we take the 40, we subtract 36, it leaves us with a 4. Now 6 still can't go into 4, so we take a 0 and we drop it down. Now 6 goes into 40 6 times again, which is 36, and we subtract it, we get a 4 again. So I think you can see by now where this is going to go. This number is going to keep going on forever and ever. We're going to keep getting the same result. So we can just put a line on the top here which indicates that this number will keep repeating forever to infinity. So our answer would be that 4/6 is equivalent or equal to 0.666666 forever and ever, and we indicate that by that line over the number. Now you'll notice in this answer that I only had 1 6 because we don't have to keep repeating a number over and over again if it repeats. But how do we know it's equivalent? Well, they are equal to each other. They are the same value, so they are equivalent. Let's try writing some rational numbers in equivalent forms. When you're given a decimal, it can be written as a fraction as well. So let's start with the decimal. But first we need to go back over what those decimal places really mean. So let's take this example of 0.12. The 1 in this decimal is called the tenths place, so that'd be 1/10. The 2 in this example is the 100ths place, so it would be 1/100th for every number that's there. So technically that would be 2 100ths. But the whole number itself, the 0.12, could be called 12 100ths. So just another way to write these things. This is also important. These are equivalent fractions, right? So here we go. Let's look at a real example from beginning to end with a decimal. So we'll start with the number 0.60. Now this can be rewritten as a fraction. We could also reduce it to 6/10ths by dividing by 10 over 10. So 0.60 is equivalent to 6/10ths. Not too bad. All right, it is question time. Let's try to find the equivalent rational numbers. We'll start with 3/9. So we have 3/9. We're going to divide it. 3 divided by 9. Again, this is not 9 divided by 3. I want to make sure you understand how we do this long division. 9 does not go into 3, so we have to put the 0 in the decimal. Then 9 goes into 30 3 times. So we have 27 to subtract. 30 minus 27 gives us 3. We drop that 0 down because 9 still can't go into 3. 9 goes into 30 3 times, which is 27. So again, we get that 3 at the bottom, which means this is going to keep going on forever and ever and ever. So we have 0.3 repeating as our answer. Let's take a look at a couple of the decimal problems. We take 0.36 and we write it as 36 100ths, which is already an equivalent number. But we want to make it as simple as possible. So we're going to divide it by 2 over 2 to reduce it and give us 18 over 50. But since these numbers are both even numbers, we know we can always divide by 2 over 2 one more time. So we divide by 2 over 2 and we get 9 over 25. So 9/25ths is equivalent to 0.36. All right, 0.40. We can rewrite that as 40 over 100. And we can divide this by 10 over 10 because they're both powers of 10. And that will give us 4/10ths, which is our answer. Now technically we could reduce this one more time since they're both even, and that would give us 2/5. You get the idea. All right, students, now it's your turn. Try these ones on your own. I'll play some music for you so you have something to work to. Good luck.
Alright students, now you should know how to find equivalent rational numbers. And that's a good thing because you never know when Math Man may be asking you. So, hopefully this has been helpful to you. And until next time, we'll see you later.